No. Yes. Yeah. Okay, today we will discuss about this uplink channel sounding. Okay, so this is module 4. Okay, I left it hybrid ARQ feedback, right? And second one is a CQI feedback. I will come back to that later on. So let us see what is this uplink channel sounding, and what is the importance of this. Okay. Yes, channel sounding is basically used for uplink channel quality measurement. Okay, at the E node B, like hybrid ARQ and CQI is used for downlink channel quality measurement. Okay, similar to that, for this uplink channel quality measurement is done by using channel sounding. We use a sounding reference symbol. Okay, we say it is SRS. Okay, that is transmitted by the user equipment in the uplink for the ENB to estimate the channel state information. Okay, the sounding reference symbol is transmitted by the user equipment in the uplink for the E node B to estimate the channel state information. The channel state information consists of MIMO channel of the desired signal, signal to interference noise ratio, then noise, and as well as the interference level. Okay, so CSI information includes these things: SINR, noise, interference level, etc. Okay, that is required to know what is the channel quality. Okay, so that information will be transmitted from the user equipment through SRS, that is sounding reference symbol, okay, to the ENB to understand what is the channel quality in the uplink. So as I said, sounding reference signal, right, can also be used for uplink timing estimation and as well as uplink power control. In addition to carrying channel state information, it can also be used for uplink timing estimation and as well as uplink power control. Okay, and this SRS transmission will be the last SC-FDMA symbol in the configured subframe. Okay, on which the physical uplink shared channel data transmission is not allowed. So last SC-FDMA symbol is the SRS transmission. So SC-FDMA is the multiple access scheme, it's a modulation scheme used from uplink to the ENB, that is from user equipment to the ENB. So the ENB can either request an individual SRS transmission from the user equipment, or it can configure the user equipment to periodically transmit the SRS. Okay, that periodicity may take any of these values. It may be transmitting the SRS for every 2 milliseconds, or 5 milliseconds, or 10 milliseconds, or 20 milliseconds, 40 milliseconds, 80 milliseconds, 160 milliseconds, and 320 milliseconds. So this is the periodicity of the SRS transmitted from the user equipment to the ENB, which will convey the channel state information. So as I said, that consists of SINR, noise, interference level, etc. That will indicate the uplink channel quality. So the user equipment specific SRS parameters are these things: the physical resource block assignment, then what is the duration of the SRS transmission. Just now I said it will be transmitted every 2 millisecond, 5 millisecond, 10 millisecond, and so on, right? So there are different periodicity levels. Then SRS periodicity, SRS subframe offset, SRS bandwidth, then what is the frequency hopping bandwidth, and cyclic shift. Okay, so these are the different user equipment specific SRS parameters, and these parameters are semi-statistically configured by the higher layers. So the user equipment need not transmit the SRS. Okay, in some of the scenarios, the first scenario is if the SRS and the PUCCH format, like a 2A 2B transmission, happens to coincide with the same subframe. In that case, UV need not transmit the SRS. And the second case is whenever the SRS and the positive acknowledgement or negative acknowledgement and positive SR transmissions happen to coincide in the same subframe. Okay, unless the parameters simultaneous AN and SRS is true. In that case also it need not transmit the SRS. Okay, these are the two situations or scenarios in which the UV need not transmit the SRS. So if the user equipment is equipped with the two transmit antennas, okay, then it alternates between the two antennas every time the SRS is transmitted. Okay, so that will allow the ENB to select the transmit antenna if the closed loop antenna selection is enabled. So that is about SRS, okay, sounding reference signal. So what is the purpose of that? Yes, what is the purpose of SRS? I said channel sounding, right? Is used for uplink channel quality measurement at the ENB, right? So that channel quality measurement will be carried by the sounding reference symbol SRS. It will be transmitted from the user equipment in the uplink to the ENB, right? So that will estimate the channel state information. I said that contains SINR, noise, interference level, etc. And this can also be used for uplink timing estimation and as well as for uplink power control, right? So the last SCFDMA symbol is used for this SRS transmission. And I said ENB can either request an individual SRS transmission from the user equipment, or it can configure the user equipment to periodically transmit the SRS. I said the periodicity of the SRS may take any of these values, that is 2, 5, 10, 20, 40, 80, 160, and 320 milliseconds. And I said the user equipment specific SRS parameters are what is the duration of SRS transmission, what is periodicity, and is subframe offset, SRS bandwidth, frequency hopping bandwidth, and as well as the cyclic shift. So these parameters are semi-statistically configured by the higher layers. And user equipment need not transmit the SRS in these two scenarios. First one is if SRS and PUCCH formats like 2A 2B transmission happens to coincide in the same subframe. Okay, in that case, user equipment need not transmit the SRS. The second scenario is whenever the SRS and this positive acknowledgement and a negative acknowledgement and as well as the positive SR transmission happens to coincide in the same subframe. Okay. And if the user equipment is equipped with two transmit antennas, I said it will alternate between the two antennas every time the SRS is transmitted, so that the ENB is able to select the transmit antenna if the closed loop antenna selection is enabled. The second thing is the buffer status reporting in the uplink. So this buffer status report is sent from the user equipment to the serving ENB. This provides the information about the amount of pending data in the uplink buffer of the user equipment. Okay. So you might have experienced when you are sharing some information, okay, from your WhatsApp to the email. Okay, so sometimes it will say it is in queue, so that will be stored in the buffer. So this is what about the buffer status report. So the buffer status report along with other information like priorities allocated to different logical channels is useful for the uplink scheduling process. Okay, that is used to determine which user equipments or the logical channels should be granted the radio resources at the given time. So to say the buffer status report will be sent from the user equipment to the serving ENB to provide information about the amount of pending data in the uplink buffer of the user equipment, right? So along with this buffer status, other information like priorities allocated to different logical channels. Okay, that is useful for the uplink scheduling process. To determine which user equipments or the logical channels should be granted radio resource at the given time. So here the buffer status reporting, right? A BSR will be triggered if any of the following events occurs. Means here we classify this as a regular BSR, then padding BSR, then periodic BSR. Okay, so these are the three different events occurs. Let us see what is regular BSR. In case of regular BSR, the uplink data for the logical channels becomes available for transmission, and either the data belongs to the logical channel with higher priority than the priorities of the logical channels for which the data is already available for transmission, okay, or there is no data available for transmission for any of the logical channels. In such case, we call this as the regular BSR, that is a regular buffer status reporting. Okay. What I said is when the uplink data for the logical channel becomes available for transmission and either the data belongs to the logical channel with higher priority than the priorities of the logical channels for which the data is already available for transmission, or there is no data available for transmission for any of the logical channels. In such case, we call this as a regular BSR. And the second one I said the padding BSR. So the padding BSR happens when the uplink resources, okay, are allocated and the number of padding bits is equal to or larger than the size of the BSR MAC control element. Okay. In such case, we say it is a padding BSR. Right. So what I said, the uplink resources are allocated and the number of padding bits is equal to or larger than the size of the BSR MAC control element. Okay, that situation we call it as a padding BSR. Even when the serving cell changes, okay, when the serving cell changes, that case also is referred as regular BSR. And the retransmission BSR timer expires and the user equipment has data available for transmission. That case is also referred as regular BSR. Okay. When the serving cell changes itself, that situation is also referred as regular BSR, I said. Then the retransmission BSR timer expires and the user equipment has data available for the transmission. That case is also referred as regular BSR. And the periodic BSR timer expires. Okay. So that situation is referred as periodic BSR. The buffer state is reported on a per radio bearer group basis. Okay, so what is that radio bearer group? So that is defined as the group of radio bearers with similar quality of service requirements. Okay, and belong to the same QCI, that is a quality of service class identifier. So there are 15 quality of service class identifier, right? So that depends on the modulation order. Okay, so there are two BSR formats used in the LTE uplink. One is a short BSR and second one is the long BSR. So the short BSR will be reported only one radio bearer group, and the long BSR reports multiple radio bearer groups. So that is the difference between short BSR and the long BSR. So this short BSR reports only one radio bearer group, and the long BSR reports multiple radio bearer group. I said, what is radio bearer group? So radio bearer group is a group of radio bearers with a similar quality of service requirements and belong to the same quality, that is same QC, that is same quality of service class identifier. Okay. That is the radio bearer group. Yes, for regular and periodic BSR, if more than one radio bearer group has the data available for transmission in the TTI, right? So where the BSR is transmitted, in such case the long BSR is reported. Otherwise, the short BSR will be reported. I said short BSR is only one radio bearer group, right? A long BSR is for multiple radio bearer group. Okay, for padding BSR, when the number of padding bits is equal to or larger than the size of the short BSR plus its subheader. Okay, but smaller than the size of the long BSR plus its subheader. Okay, in such cases, we go for padding BSR. Right, so truncated BSR with the highest priority logical channel is also reported. So if more than one logical channel group has the buffer data, so otherwise the short BSR is reported. So to make clarity, I said there are two BSR formats used in the LTE uplink. One is short BSR, second one is long BSR. The short BSR reports only one radio bearer group, and the long BSR reports multiple radio bearer group. Right. So before that, I said about regular, periodic, and padding BSRs. Right. So when do we say it is a regular BSR? When do we say it is a padding BSR? When do we say it is a periodic BSR? Right. So those things will be reported based on the number of radio bearer groups, right, as the data available for transmission in the TTI. So in such cases, the BSR is transmitted, that BSR will be the long BSR. So otherwise, it will be a short BSR. So here there is a condition, if more than one radio bearer group, that means that is for long BSR. Right? Otherwise, it will be a short BSR. So the padding BSR is used when the number of padding bits is equal to or larger than the size of the short BSR plus its subadder. Okay, but it is smaller than the size of the long BSR plus its subadder. So truncated BSR with the highest priority logic channel is reported if more than one logical channel group has the buffer data. So this is for even under padding BSR. So this is all under long BSR. But otherwise, there will be a short BSR is reported. So if the number of padding bits is equal to or larger than the size of the long BSR plus its subheader, so in that case, the long BSR is reported. Right? So when the BSR procedure determines that at least one BSR has been triggered, and then if the user equipment has been allocated uplink resources, then a buffer status report is transmitted. If a regular BSR has been triggered and the user equipment has no allocated uplink resource, right, then a scheduling request for the BSR transmission will be triggered. Okay. If a regular BSR has been triggered and the user equipment has no allocated uplink resource, okay, in such case, a scheduling request for a BSR transmission will be triggered. So a MAC PDU contains at most one MAC BSR control element, even when multiple events trigger. So in that case, the regular BSR and the periodic BSR will have the precedence over the padding BSR. Okay. So I said MAC PDU contains at most one MAC BSR control element, even on multiple event triggers. Okay. In that case, the regular BSR and the periodic BSR will have the precedence over the padding BSR. So all the triggered BSRs will be cancelled in these two scenarios. The first scenario is when the uplink grant can accommodate all pending data available for transmission, but is not sufficient to additionally accommodate the BSR MAC control element. In such cases, all these triggered BSRs will be cancelled. And the second case is when the BSR is included in a MAC PDU for transmission. In that case also, all these triggered BSRs will be cancelled. Yeah, this is about BSR. Okay. So two things I discussed. One is scheduling. There is a channel sound reporting, right? Channel sounding in the uplink. I said we will be using SRS for that, right? That is a sounding reference symbol. I said what it all contains, what is its importance. In addition to CSI, what it can also carry, right? The next thing is I discussed about the buffer status report, that is BSR. So this BSR, as I said, this buffer status report will be sent from the user equipment to the serving ENB to provide information about what the amount of pending data in the uplink buffer of the user equipment. So how it is reported. So for reporting that, there are various techniques, right? So we trigger that BSR in these events. I told about regular BSR, pending BSR, then periodic BSR. Then I said that buffer status report will be done based on a per radio bearer group. I said what is that radio bearer group? Is the group of radio bearer with similar quality of service requirements and belong to the same quality of service class identifier. So there are two formats used in the LTE for uplink, that is BSR format. One is short BSR, second is the long BSR. I said that the short BSR will report only one radio bearer group, and long BSR reports multiple radio bearer groups. So these are the different scenarios with which we say it is regular periodic and is the padding BSR. Okay, scheduling and resource allocation is the next topic in that module. So the main purpose of the scheduling and resource allocation is to efficiently allocate the available radio resources to the user equipments. Okay. So that is the purpose of scheduling and resource allocation. What? It has to allocate the available radio resources efficiently to the user equipment so that it can optimize certain performance metrics with the quality of service requirements constraints. So in LTE, these scheduling algorithms are divided into two groups. One is channel dependent scheduling and second one is channel independent scheduling. Okay, in case of channel dependent scheduling, the allocation of the resource blocks to the user equipments is based on the channel condition. Okay. That is why it is called channel dependent. In case of channel independent scheduling, the allocation of the resource block to the user equipment is random and not based on the channel condition. You might have heard about this round robin scheduler. Okay. So in LTE, right, the channel dependent scheduling is again further subdivided into two types in channel dependent, right? So one is the frequency diverse scheduling. So in this case, the user equipment selection is based on the wideband CQI, that is channel quality indicator, and the PRB allocation is in the frequency domain, and it is random, and it can exploit time selectivity and as well as frequency diversity of the channel. Okay. So basically there are two types of resource scheduling, right? One is channel dependent, another one is channel independent. In case of channel dependent, I said the allocation of the resource block depends on the channel condition. In case of channel independent, allocation of the resource block to the user equipment is random and not based on the channel conditions. Right? Again, in case of channel dependent scheduling in LTE, further it is divided into two types. One is frequency diverse scheduling. I said here the user equipment selection is based on the wideband CQI, and the PRB allocation will be in the frequency domain, and it is random, and it can exploit time selectivity and as well as the frequency diversity of the channel. And the second one is the frequency selective scheduling. So here the user equipment selection is based on both widebands and as well as subband CQI, and the PRB allocation, okay, is based on the subband CQI. It can exploit both time and as well as frequency selectivity of the channel. Hence, this dynamic channel dependent scheduling is one of the key features to provide high spectrum efficiency in the LTE. So to better exploit the channel selectivity, the packet scheduler is located in the ENB. Okay, that will allocate the physical layer resources for both the downlink shared channel and uplink shared channel transport channels every TTI. Okay, so the scheduler will be located at the ENB only, right? So that it can allocate the physical layer resources for both downlink shared channel and as well as the uplink shared channel every TTI. Resource assignment consists of PRBs and as well as MCS. That is, MCS means modulation and coding scheme. PRB is physical resource block, right? So resource assignment has these two things. One is PRB, another one is MCS. The scheduling depends heavily on the channel information available at the ENB. So that will be provided by the uplink CQA reporting for the downlink channel, and by this channel sounding for the uplink channel. So just now I discussed about this channel sounding, right? How it is providing information to the ENB about the quality of the channel. So for downlink, I said it uses CQA. So that scheduler also take account of the traffic volume and as well as the quality of service requirements of each of the user equipment and associated radio bearers. Since we are using OFDMA in the downlink and ACFDMA in the uplink, so LTE is able to exploit the channel variation in both time and as well as frequency domain. Okay, but in case of HSPA, it is used to exploit only the channel variations in time domain. So the objective of the channel dependent scheduling, okay, is to exploit multi-user diversity to improve the spectrum efficiency. Okay. In addition to that, it can also consider the issues like fairness and quality of service requirements. Okay. In addition to that, the scheduling is tightly integrated with the link adaptation and the hybrid ARQ process. So I think this hybrid ARQ process already have discussed that. And this scheduling algorithm is not standardized, and it is a eNode B vendor specific. Okay, so each eNode B vendor can decide its own scheduling algorithms. Yes, Bharat. Bharat. Bharat Kumar. Mani Ratna. Mani Ratna. Ratna ಇಲ್ಲ ಭರತ್ ಕುಮಾರ್ ಇಲ್ಲ ನಾನು ಸುಮ್ಮನೆ ಪಾಡಿನ ಹೊಡಿತಾ ಇದ್ದೀನಿ. ಎಸ್ ರಶ್ಮಿ.
Yes, sir.
Listening.
Yeah, sir.
Can you just
I came just a few minutes before,
oh,
sir.
you came just few minutes
9:15.
back. Means you
Yeah, sir.
heard about channel sounding or buffer status report?
No, sir.
No, at least I heard about scheduling and resource allocation. I just started.
Yeah, sir. I heard.
Can you tell the importance of scheduling and resource allocation?
In operating system, it is used also.
Yeah, operating system only, but you have to tell with respect to this communication system,
Uh,
scheduling and resource allocation.
so
I said, no, why it is required? I said, no, what is the main purpose of scheduling and resource allocation? At least that point you can tell.
in communication, with respect to communication system,
Yeah, with respect to communication.
uh, to determine like which user will be active
Mm,
at
which
certain
user will
time,
be
like that.
active?
I mean, which user will be active at the certain time to allocate that uh,
Hmm.
time slot. I mean, should time slot should be given for the user. Maybe that thing.
Grass ನೀವು ತಗೊಂಡಿಲ್ಲ. Hmm. Okay, I said that the purpose of scheduling and resource allocation is to efficiently allocate the resources to the user equipments.
User,
Okay,
yes.
available resources. Here, resources are what in communication?
Uh,
Resource is what? It is a
bandwidth, bandwidth.
bandwidth, frequency, power. They,
Uh,
uh, these are the resources. Okay, so frequency, power, bandwidth need to be utilized as efficiently as possible.
yes.
So that is the main purpose of uh, scheduling and resource allocation.
Yes.
Mm, okay, then I think I was talking about other than that what I said in scheduling and resource allocation. Any idea?
No, sir.
No. Mm, yeah, I talked about different types also. I said broadly two types. One is channel dependent scheduling as far as scheduling is concerned. Okay,
Yes.
channel dependent. Second one is channel independent. So in case of channel dependent scheduling, the allocation of the resource blocks to the user equipment is based on what? Channel condition. Okay.
Yes.
So channel condition will be determined based on what? Carrier interference, right? Carrier to interference ratio and other things. And second one is channel independent scheduling. Here the allocation of the resource blocks to the user equipment is random and not based on the channel condition, I said. So I think this round robin scheduler you might have studied in OS, what I feel.
Yes, sir. Yes, sir.
Uh, okay. Then in the LTE, I said in case of channel dependent scheduling, two types of scheduling is used. One is frequency diverse scheduling, and another one is frequency selective scheduling. Right. So this frequency diverse scheduling. In this case, the user equipment selection is based on the wideband CQI set, and the PRB allocation is in the frequency domain, and it is random. So it can exploit both time and as well as frequency diversity of the channel. That is the frequency diverse scheduling. And frequency selective scheduling, in this case, the user equipment selection is based on the wideband and subband CQI. Okay, here the PRB allocation is based on the subband CQI. Okay, and here it is possible to exploit both time and as well as frequency selectivity of the channel. But in case of this frequency diverse, now only time selectivity and frequency diversity of channel is exploited. And I said that this dynamic channel dependent scheduling is one of the important key features, okay, that provides high spectrum efficiency in LTE, right? So to better exploit the channel selectivity, I said the packet scheduler is located at the ENB. That will allocate the physical layer resources for both downlink shared channel and the uplink shared channel for every TTI. Okay. So the resource assignment consists of, I said, two things. One is PRBs, another one is modulation and coding schemes. Okay. So here two things I discussed about this. Scheduling depends on channel information available at the ENB that is provided by what I said, channel CQA reporting for the downlink channel and channel sounding for the uplink channel. Right? And this scheduler also takes into account of the amount of traffic volume and the quality of service requirement of each of the user equipment associated with the radio bearers. Okay. Since I said OFDMA and SCFDMA is used in LTE, I said OFDMA is implemented for downlink, SCFDMA is implemented for uplink, right? So that enables uh, to exploit the channel variation in both time and as well as frequency. But in case of HSPA, so this is a 3G plus standard. Okay, there it could exploit only the channel variation in the time domain. Okay, so I was talking about what is the objective of the channel dependent scheduling, right? Its objective is to exploit multi-user diversity to improve the spectrum efficiency. In addition to that, it has to consider the issues of fairness and quality of service requirements, and as well as the link adaptation library RQ processes. Okay, I think let me discuss this in the next class, I feel. 925. Signaling for scheduling in downlink and uplink. Yes, any questions? Vaishnavi?
No, sir.
So, ಸ್ವಲ್ಪ operating system concepts use ಆಗುತ್ತಾ?
Sir.
You people have studied operating system? Yeah, scheduling.
I did not study the subject, sir. I had taken another elective. But
Okay.
this concept I have not, sir.
Okay. Okay, then. Yes, what about Neha?
So,
Would you understand the importance of channel sounding, BSR, then scheduling and resource allocation?
yes, so.
What about Namrata? Namrata. What Sushmita, you are joining now? Sushmita. Okay, I think you can enter your equation in the chat box. Okay.